Hello guys, anybody there? 10 minutes before I started streaming, the internet went down here and now things are a bit awkward, so I have to test that everything is working properly, especially because I'm streaming from my cell phone. So please give me some feedback. If you're there, give me some feedback if you can listen properly, if everything is okay. Is anybody there? 10 minutes before I started streaming, the internet went down here. And some feedback if you can listen properly, if everything is okay. Is anybody there? 10 minutes before the. Well, I'll do what I usually do. I'll start the streaming session and I'll start showing some of the tools and some of the repositories that are available here. So this tutorial is part of a larger project. This project, I'm a professor here in the university. The university is called Federal University of Rio Grande do Norte in Brazil, in a city called Natal. My name is Leonardo Bezerra. I am a researcher, developer, and professor, pretty much in that order. The name of the city is Natal in Brazil. The name of the institute is Metrópole Digital or Digital Metropolis. And here I'm a professor where I teach two major courses, two major set of courses. One is focused on problem solving, computational thinking, and programming. And for that, there are some live tutorials that I'm running. There's three repositories that focus on these: Python 0, DS 0, and Python dots, which would be abstract data types. And all these three are in Portuguese, so if you're in Brazil or if you know Portuguese, you can make use of them. If you cannot, I have other notebooks that are related to data science and machine learning. So Pandas 0 is the one we're going to be addressing today, and DS 0 is still in Portuguese, will be translated later, and Scikit 0, which is being done now. So Pandas 0 is the idea of data science for non-programmers. Scikit 0 is the idea of machine learning for non-programmers. So on Tuesdays at this time, I'm going to be using Pandas 0. On Thursdays at this time, I'm going to be running Scikit 0. Okay, so let me show you Pandas 0 now, just for a starter. The idea is we have data sets. We have basically like this README where you can choose if you're going to follow it in English or in Portuguese. So the file structure is not really important. If you choose English like I did, you see some introduction here, and we're slowly adding notebooks here. So the Portuguese version, the Brazilian Portuguese version is complete, but it's being translated gradually. So this repository has been made by students at the university, and now there's a group of students that is translating the Portuguese version to the English version, and I'm reviewing them one by one. So even if they have submitted, sometimes they're still not here because I'm still reviewing them. If you're not familiar with the context of GitHub, well, you don't really have to understand the backgrounds on GitHub. What we're going to do here is that when you're working with data science, you have basically two types of tools that you can use: graphical user interface tools, which are like everything is graphical. So you're talking about Google Spreadsheets, Orange 3, and other kind of data science tools like that. And the other option is that you do command line interface. So the idea is that here we're going to use a programming language to interact and do our analysis. It's not really programming because we're using very high level commands, and I'm going to make it as simple as possible for people who do not program, because this is the focus of the project. And we combine these two worlds, like having something graphical and something that is command line based, using Jupyter notebooks that we're going to run through Google Colab. Okay, so the main programming languages that you can use in the context of data science and machine learning are probably Python, R, and Julia. I could include here MATLAB, since so many people in engineering use it, but MATLAB has a very expensive licensing, so I will not go that way. I'll just mention the open source versions the three versions, which are Python, R, and Julia. I discuss a bit Python and R here. I don't have much experience with Julia, save that my kid is named Julia. The idea is we can go now and say, okay, I want to launch this, I want to try this. What I do is that I click here and open in Colab. We're going to run these first steps, and this one is going to be in English, right? So I will go back quickly to the live streaming to see if anyone has left a message on chat. If you have any questions, you can ask. Fortunately, the number of concurrent viewers has risen. I think many people were here at the time, but we lost many people because I had these internet issues. Fortunately, we're back, so if you have any messages you wanted to send on the chat, like it's going too fast, I'm not listening very well, the connection is not so great, you please tell me, because I'm always switching back between the chat and the presentation, right, the tutorial. There's a gap that is always there, like this delay. Every time I talk to you, it takes like between 15 to 20 seconds for you to hear what I said. That's part of the streaming protocol. And basically what I'm gonna do is that I'm gonna wait for you to reply. When you reply, I can answer. And sometimes I'm gonna just say, okay, I'm gonna answer now. I'll move back to the tutorial. When I stop again to check the chat, I will reply to the questions that have been made while I was presenting, okay? So please say, okay, go on, or no, slow down, I have some issues, the connection is not so good, please let me know, okay? I can answer, and sometimes I'm gonna just say, okay, I'm gonna answer now, I'll move back to the tutorial. When I stop again to check the chat, I will reply to the questions that have been made while I was presenting, okay? So please say, okay, go on, or no, slow down, I have some issues, connection is not so good, please let me know, okay? Well, no questions so far. This is what we're gonna do. I invite you to do the same thing I did, to open GitHub, to find my user, Leo Bezerra, so I'm gonna type it again, github.com, Leo Bezerra, and then here you can find Pandas 0, okay? And then from Pandas 0 you choose English, you click on the Colab button, for the first one, first steps, open Colab, and you're gonna get the same screen I have here. The good thing about this is that you can test things, okay? So this is very important. I need you to test things because Colab is made so that we are doing something interactive here so that you can actually have questions and I can help you answer them, okay? So first steps with Pandas for data analysis. This was a tutorial that was originally created by one of the students, Jonathan, and I reviewed it and I upgraded it and made a few changes. And it was translated by other students. They're also credited in the GitHub. The idea is that in this tutorial we're going to start talking about tabular data, okay? So if you have no idea what tabular data is, there are some, if you go to my Medium, you're going to find a post that explains the basic concepts on tabular data. And let me find you a way to get there so that you understand the basics. So there's another repository called DS0, Data Science 0. It's still in Portuguese. But there I have a post from Medium that will show you the idea of what is tabular data, right? So basically tabular data is how we organize, we refer to data that is organized as a table. You probably have used that sometime in your life as in a spreadsheet, right? So we have rows and we have different names that we can use for rows. Here in this post I was using observations. When I'm speaking I'm gonna switch between observations and samples. It depends on what you want to use. Some people more for databases will say registries or entries. Well, there are many names you can use, but basically the rows represent actual observations that you have made or samples that you have collected, okay? Columns on the other hand, they represent features. they represent attributes of the data. Okay, so if I show you one example here, I know that the zoom is not very big, but the idea is that here it's a New York City Airbnb dataset. Each entry is a user, actually is a location that you can rent, and then you have the characteristics like the name of the location, the ID of the host, the name of the host, the neighborhood where it is, latitude and longitude, and so far, okay, and so forth. The idea is for each observation of this, which represents something that was posted in some place that is posted, that is listed in Airbnb, you have all the different attributes, right? So that's tabular data, basically. It's not like what we used to do with spreadsheet when we're doing, like when you're changing the font size or highlighting or grouping or merging cells. That's not it. Like tabular data has to be basically the rows and the columns, right? And you're not supposed to have blank spaces. Here you can see an example that sometimes that happens, but that's called missing data and we have to deal with that. So ideally, a tabular data set would have all the rows and all of the columns filled out, right? So the idea is that a value in a given cell is the actual data we have about a given feature of a given observation, right? So the value that I see in a given cell there is, for instance, the name of the neighborhood where that location is located, okay? So basically the kind of things that we use to represent tabular data are either spreadsheets, like you might have used OpenOffice, Microsoft Office is a bit more known, Google has spreadsheets, there are other options that you can try, or you can represent as a text file. And basically a spreadsheet represented as a text file or tabular data represented as a text file is just something that follows a given structure, right? As long as it's properly structured, you can read it, you can write to it. So one of the structures is called delimiter separated, so we call it CSV. So that same data set presented as a CSV has, for each row, it has, for instance, the header here has the name of the observation, comma, the name of the first feature, comma, the name of the second feature, and so on. And then from the second row on, you have the data for the observation, right? So the ID for this observation is this, comma, the information for the name for the location, and so on and so forth, right? We can also have a different kind of structure, like in JSON, where you have, it's a bit more verbose, so the name of the features are being repeated all the time. It's also a bit more readable, right? So here I know that for the first observation, I'm saying that the ID is this, the name is this, the host ID is this, right? And then the second observation has this one, but it also takes much more space, right? So anyway, you don't have to deal with this bottom level, like in a low level, but the programs you're going to use to read and manipulate this will have to, right? So the idea is that the data set you load will either be showing you as a data table or a data frame. So Orange 3 uses the concept of data table. So you get this table, and many spreadsheets will use these data sheets or data tables. And in Pandas, which we're going to use here, you use the concept of data frame, right? A data frame is a structure that will help you manipulate things. So let me go back to Colab, and let's start with this. I want to import Pandas, but first we have to get the data we're going to use, right? So here columns will be referred to as features, rows will be referred to as samples. I'm going to try to connect to, so the idea here is that I was trying to show how we can do this using Google Colab, right? So in Colab, if I want to have data, the first thing I have to do about Colab is connect. So the idea is that a Colab will run in a machine at Google's infrastructure. The thing is that you don't really get a computer. You get to run your program in a computer, but to make sure that there are like security issues that are respected and all this kind of stuff, your code is run on what we call a virtual machine. So a virtual machine is just a program that simulates that you're using an actual computer, right? So a single computer can run several virtual machines at the same time. Nowadays we call them containers. So a computer can host several containers. Your script, your Colab is running one of those containers. You think you have the whole machine for yourself. and it's completely transparent. You don't know that other people are running code, and in principle they do not have access to your code or your data, and vice versa, right? So here you can see that there's RAM and disk. I can see like information. I have RAM allocated, disk allocated, and I know how much I can use. So here I can use up to 12 gigabytes of RAM and 100 gigabytes of disk. So probably this RAM is even more than you would expect for a simple container, but yeah, you generally don't push this so hard, because unless you're dealing with very large data sets for computer vision or natural language processing or big data in general, right? So what I will do here is that I will download the data set. The data set comes as a zip file, so I can. Kaggle is a website that hosts a lot of data sets, so this is interesting for us. I will log in with my Google account. Actually, I think I'm already logged. Okay, so it's price for different types of oil, gasoline, ethanol, and this kind of alcohol and this kind of stuff. I can click here in download, and I'm gonna download the file. I'm gonna save the files, combustible price Brazil. I'm gonna save it, and then I come here in the files tab, and I can click upload and choose what I want to upload. The only thing I have to do here is that I have to unzip the file, so give me a minute just to unzip the file, and you can do it that too. So here it's unzipped, and the name of the file that was inside. So this is a Brazilian data set, so in the beginning, if you do not speak Portuguese, if you're not from Brazil, you find the information a bit. So one thing that it reminds you is that when you submit a file here, you upload a file. When the runtime is recycled, that means when you stop using it or you reach the maximum time you can use, it's gonna get discarded and it's gonna go away, right? So every time you run a collab, you have 12 hours of allocation for that container. They call it a runtime. And when you exceed those 12 hours, it gets recycled. You can start a new one. It's not a problem, but you're starting a new one, so you lose all the things that you had before, right? So that's why I wanted to show you how to use Google Drive. So actually, I uploaded it here. We can use it from here. But so if you wanted to use it from here, you could. But I'm going to show you how to do it with Google Drive. So let me open my Google Drive here, drive.google.com. So the idea is that I would have to upload the file here. I'm pretty sure I already have this file, so let me check. Yes, I have the file here. So I do not have to upload it again. If you do not have it, you just upload it, okay? So what I do here is that I run this cell because I want to connect this collab to my Google Drive. So now I'm going to talk about files that do not get deleted, right? So I run this. Every time I run a cell, it's going to tell me, okay, so the first time I run a cell actually, it's going to tell me, dude, this notebook was not authored by Google. Are you sure you want to do this? Yeah, in this case, yes. So run anyway. And then it's going to tell me, oh, please click on this URL, sign into your Google account, and give me the code that you're going to get. So here I'm saying, okay, I'm going to use this account to allow Google Drive file stream to access my Google Drive file stream, okay? So allow, and it gets me a code. I paste it back here, and then now Colab has access to my drive, right? So when I see here again, it's still running. Can you see it here? When it finishes running, I'll be able to see the file there. Yes. So it says mounted at and then the directory. If you use it to Windows, you will use it to C, D, E, the volumes there. Here, because it's Unix based, it's slash something, okay? But for you, it's not a problem. You just come here, you navigate to the file that you want to read. So my drive, it should be here, disciplinas. I hope it's here. Yes, it's here. Good. And then I say copy path, okay? So I found the file. This is the directory structure from my drive. So if I go here the same way, disciplinas, ML for machine learning, I see the file here, okay? So I just navigated it in a tree-based format. So let me close these things here. And then now that I copied these, I click on right click and copy path. I can come here and say, okay, I want to read it, right? How do I read it? Well, I'm gonna use Pandas. Pandas is the most used library for data science in Python. And because probably Python is the largest data science community in the world, it could be that Pandas is the largest more widely used, most widely used data science library in the world. I'm not sure of that data, but I have this very strong suspicion, right? So from Pandas, well, we don't know Python, that's not a problem. By the way, there's a repository for that if you want to learn. But the idea is, I'm going to say I want to get from Pandas just the method read CSV. So the file I uploaded is a CSV file, which I showed you in the Medium post. And I'm going to say, okay, please Python, I want to use this read CSV, okay? And then I am going to do exactly that. I'm going to say read CSV. And notice that there's a suggestion here on what you can use. At this first moment, you're not understanding it, but this is basically the documentation of the method, okay? Here I'm gonna put the path, and I have to do it enclosed in quotes, okay? So in Python, everything that is enclosed in quotes is called a text, okay? A string. And this is how I say, okay, please read these, okay? So I said that, now I can say, okay, this is gonna create to me a data frame. So you're gonna visualize this here. So now we have the data frame here. Don't worry that the things are in Portuguese. We're going to translate them in a minute. You're going to learn how to do that. Especially because, I mean, that might be helpful if you're speaking, you're not from an English native country, and sometimes you want to translate things for the language in your country. Well, if we just do this, the data frame is visible here, but there's not much we can do because this is not interactive. This is just printed out on the screen, right? So how do we interact? We have to say, okay, I want to refer to this data frame by a name. I'm going to call it data. I'm going to call it df because it's very common to see notebooks where people call it df. And the notation is this. I say df equals and then the read CSV, because what I'm saying is this. So when you create this data frame here, please, I want to associate with the name df. I'm going to be referring to it as df. Okay, so df, short for data frame. If well, this is the whole idea for reading a CSV file. There are many ways of reading. This is one that connects you to Google Drive. I'm going to switch back to the chat now to see if there are any questions. And then if there are not, I can proceed. So let me switch. I'm going to be referring to it as df. Okay? So df, short for data frame. If well, this is the whole idea for reading a CSV file. There are many ways of reading. This is one that connects you to Google Drive. I'm going to switch back to the chat now to see if there are any questions. And then if there are not, I can proceed. So let me switch. Okay, since there are no comments, I'm gonna move on. And the idea is that that's how we read a CSV file. We don't stop there. We're gonna move on. We're gonna move on to the idea of how do I explore the data, right? So now I have a data frame here. I'm referring to it as df. And I want to see, for instance, the number of features and samples. So notice that this code here has a hashtag starting the line. That's called a comment. So if I try to run it, nothing's going to happen because this comment is commented out. What I'm going to do is that I'm going to uncomment it and I'm going to run it. Okay. And basically, when I have the name data and I say dot something, I'm saying either perform an action on the data. Actually, I switch it to df, right? So actually, either perform an action on df or get some attribute from df. In this case, attributes refer to the object, not to the data frame content. So I'm only gonna refer to the data frame columns as features from now on, right? So the shape is basically the number of samples times the number of features, okay? So if I want to see some of the observations, I can use the method head. So I'm going to switch it here to df. If I don't provide, so when you're talking about a method like head, you use parentheses and you provide some parameter. So if I do this, I'm going to see the first 5 lines, okay? If I don't do this and I choose a number, it's going to show me just the number of samples that I asked, okay? So if you see here, ask for 3 and I get samples starting at 0, 1, and 2. So in general, by default, we're going to say that the indexing for most of the things in Python, if not all, start at 0 and end at the number of things you want minus 1, okay? So it starts at 0, it ends in 2 because I asked it for 3, okay? Well, this is something that is basically in computer science. Some languages don't do that because they're niche specific, like R or MATLAB. But in all computer science originated programming languages, you're gonna find zero-based indexing, right? Well, the same thing you can do that will provide you a similar result is instead of getting the head, I'll ask for the tail, which means that instead of getting the first rows, I'll get the last rows, right? So since I didn't say any number of observations, I'm getting here 5, okay? I could configure this. And the idea is that, so df, another attribute that we have is the list of columns. So Pandas is a bit verbose, but what we want is this, okay? We want this, which basically is a list of the column names, okay? So I have isolated them here. A list in Python has this notation, like start with, it's enclosed in brackets, square brackets, and each element is separated by a comma, right? In this case, since each of the elements is a text, is a string, it's also, each element is also enclosed in quotes, right? And it doesn't matter if it's single quotes or double quotes, okay? So now if I want to translate this because you're not understanding anything, I can just do this. So now please associate data columns to this new list. Okay, so now maybe it's easier to understand. These are the features that were there. So this is a data set that aggregates the prices that were collected from gas stations across the country. And basically you have a start date for that collection process and an end date. The product that was researched, end stations, which is the number of gas stations that were interviewed during that time, the metric that was used, because if you're not talking about liquid combustibles, you're gonna talk about, for instance, natural gas, then the metric is different. The average retail price, standard deviation for retail price, minimal retail price, maximal retail price, average, well, up to here it's just descriptive statistics on retail prices, okay? We also have retail margin, retail variance, and some other features like distribution price, also some descriptive statistics. So basically when you're doing data science, you really need to know your basics in descriptive statistics. If you don't, Pandas is here, Pandas Zero is here to help you, okay? But here what I wanted to show is that you have two main kinds of objects. Well, did I run this out? No, because there's no number here, right? So every time you run something, you get an output here. So, oh, data. Yeah, it's not data, it's df. So Pandas objects and data types. We have, well, let me see if there's any questions in the chat. No? Okay. So if you pose any questions in the chat, I'll reply, okay? So let's go. We have two kinds of objects in Pandas. Actually, we call it data containers. So data frame is the one you know, right? Because we've been using so far. It's a collection of series. Each series has its own type, so each of those columns that you've seen. And each column is what we call a series, right? So a series is a unidimensional data series of the same type, either numbers or names or ages, whatever it is. So the column has a single type. A data frame is a collection of series. Each series can have a different type, right? So the idea is if I say type data, actually df, which is what we use in here, we're gonna get that it's a pandas data frame. Again, it's a bit verbose, but what matters to us is that it's a data frame. Okay. Now, if I say df.info, we're gonna get information on the data frame, and basically what it's telling is a lot of things, right? First, it's a data frame. Second, the index that we saw on the rows, it goes from 0 to 1823. There are 1824 entries or samples. The data columns are 16, and then the names of the columns. And here's the type of the data that it is using to represent that data column. So there's one column that was interpreted as being an integer, but all of the other ones, Pandas did not really know what to do with them, so it kept it as general as possible, right? So there was only one type that was assigned like this. So if you look at minimum retail price, maximum retail price, and all these things, you're probably wondering, why is this being considered general and not as real valued numbers? Because for sure these are real valued numbers, right? So this is what I'm gonna do. We're gonna discuss a bit data types, right? So object is like the most general format. If Pandas cannot go any deeper, it will stop at object. So most of the text data that you have will be represented as objects. So there's int for integer numbers, float for real valued numbers, and this is a particularity in computers, right? That you cannot represent integers and real valued numbers in the same way. So they'll always be represented differently internally, especially because operations that are related to real valued numbers are much more expensive in terms of computational time and memory. So every time it can be integer, it's going to be integer. Here there's a 64 just to say that the architecture is 64 bits, because that's what Pandas would typically do. But don't mind about that. You can just consider these integers and real values. There's also date times, for date and times, and Boolean values that are basically true and false. So sometimes the question that you ask is binary, and the answer is also binary, like it's either true or false. Well, sometimes Pandas will not be able to properly parse the features. So this is the features part. Pandas didn't parse properly. Let's see. Well, we can change this, right? So basically the same thing I got from info, I'm gonna get from D types, which are like the dynamic types that Pandas assigns to each of these columns, to each of these features. So what I'm gonna get there is this part, okay? So, well, nope, because there's no data, there's df for data frame, right? See, this is the part that I get, but it's actually better to look at this. So here it was saying that none of the values, the 1824 values, are not null, so no value was missing. Okay, this is very important to us. As I said before, ideally a tabular data set should not have no values, but this is not realistic in the real world. There are always new missing values, and we're gonna see how to deal with them, right? So here I just want to show you that we can change the type of a feature using this as type method, and we're going to use this notation, okay, right? So the notation is, I have this data frame represented by data, in our case df. Let me show you here. So I have here df average retail price. So in square brackets I say the name of the feature I'm talking about, so average retail price. And I say, so now because I'm doing this, I'm talking about this series. And then the series has a method called asType, to which I can say I want to change it to float because that's a real valued number. So please do that. And when you finish doing this, you're going to have now a series that is being represented as a real valued number. And I'm going to call it df average retail price. So basically you're replacing one with the other, right? So this reference here is now not going to be referencing anymore what was before. It's going to be referencing the new version that you created. So I'm going to do this, and there's going to be an error. The reason being that in Brazil, the decimals are represented in a different way from from what we have in English, right? Actually, the error is a different one. Let me see what happened, because at some point I might have checked something. No, it's just not finding the column. Let's check here just a bit. Let's check what is in the content of the F columns, because it's saying it doesn't find it. So what's going on? Max retail price. It's average retail price. Okay. So, well, I can change it in either place. What I'll do is I'll change it here just to keep the standard, because there's another way of writing average down here. So I want to keep them concise. So let me go back to that cell and say, okay, now it should work. Actually, it should not work but now for a different reason, which is the one I expect. Yes, this is the one I expected, which is I could not convert this text to a float, right? So I don't know how this is a real valued number. And the reason is that in Brazil, commas are used to separate between the integral part and the decimal part. And in English, we have that being done using a period, right? So this is something that we can tell Pandas and say, Pandas, please, when you read the CSV, let's go all the way back to reading the CSV again. So when you read the CSV file, please, let me get the name of the file here. I'm going to copy this code and then I just change what I need to change, okay? I'm going to say the decimal separator is the comma, okay? When I do this, it should work. So it read it. Let me see. How do you see the first one? Well, here the suggestion was that you check dynamic types to see if that made a difference. Sorry, D types. And yep, so you see that all these values are now being considered real valued, right? So this is not being considered a date or a time. The reason is that I didn't tell Pandas to parse the dates, and if I had, I would have to say how to deal with the format, because then again, the representation for date time varies from country to country. So the only objects that I already expected not to be converted were product, the metric, and this. So just for you to see, the way I did it here, you go back to other things in Portuguese, right? Because I read again from the CSV file. What I could have done instead is to go back to the beginning, where I first read, set decimal equals this, and then I can say runtime. Well, sorry, I have to comment out the last cell if I don't want it to be run, okay? So I'll say runtime, restart, and run all. And now it should work, because now it's going to run all the cells again. See, it ran all the way here, and now I see that they're correct. So if you go back, that command that didn't work, now it did, although it was not needed, it was not necessary, right? So these are the things I would like to discuss here, to talk about what is tabular data, what is Pandas, what is Colab, how do I run something, how do I download a data frame, how do I check its types, how do I change it. And these, as I said, first steps with Pandas. So there are many more things that we can discuss. But let me go back to the chat and see if there are any questions. Anyone has any question? Anyone has any comments? A data frame, how do I check its types, how do I change it? And these, as I said, first steps with Pandas. So there are many more things that we can discuss. But let me go back to the chat and see if there are any questions. Anyone has any question? Anyone has any comments? Okay, no comments, so we're gonna go now. This is what I wanted to show you today. I hope you enjoyed it. I'll be available if you wanna ask something. I'm always available at Telegram, at my GitHub, at LinkedIn, wherever you have found this. By the way, if you can provide me some feedback on where you found it, where you heard of this video, please do. Okay. For now, this is it, and I'm gonna stop the transmission if there are no more comments. Thank you very much for attending. Please click like, subscribe, or whatever way you have to interact with YouTube channel. Subscribe, or whatever way you have to interact with YouTube channel.